Hello students, and we're going to be taking a look at one last example here, one question type. So here we have one triangle PQS, and it's a right angled triangle. Within it we have inscribed PRS. We're told that the angle SPR is 30 degrees and the angle RPQ is 25 degrees. The length P to Q is 12.8, and what we're asked to find is this length R to Q. So notice that there's no direct computation for R to Q. However, if we decide to work backwards, what's the last piece of information that we needed to find RQ? Well, it's this. If we know the distance from S to Q and we subtract the distance S to R, that leaves us with our desired distance R to Q. So one of the tricks to solving a lot of trigonometric problems is thinking about what was the last piece of information required in order to finally solve our problem. So what we're going to do is we're going to break this diagram here into its two right triangle components. So let's take a look. Remembering what our goal is to find SQ and SR, and the subtraction of those two is going to give us our final answer here. So let's take a look. I have this big triangle PQS, and the first thing that we need to do is we need to be able to find out what this angle here is. So this is the angle SPQ. So looking back here, SPQ, well, it's spanned by these two angles. So this angle is 30, this angle is 25. So SPQ has to be the sum of those. So it's going to be a total of 55 degrees. So our first thing to solve for is SQ. So in order to solve for SQ, we're going to use some trigonometry here. So I want you to pause the video and try solving for SQ using your trigonometry skills. So we've labeled our sides, and let's take a look here. Well, we want to find SQ, that's our opposite. We know the hypotenuse, which is 12.8. So these are our two pieces of information that we're going to be using. So we're going to be using sine in this case, opposite over hypotenuse. So completing our work here, we know that the sine of 55 is equal to our opposite side, SQ over 12.8 meters. Therefore, using our algebra skills, we find that SQ is equal to 12.8 times the sine of 55 degrees, which to the nearest tenth of a meter is 10.5 meters. So what we're going to do now is we'd like to be able to solve for SR. But notice that we need another side of this triangle to solve for SR. Well, how can we get it? Notice that PS and PS are common to both of these triangles. So the next thing we want to solve for is for this adjacent side. Really, the first step that we're going to do is we're going to solve this entire triangle. So you have a few different ways to do this. What you could do is you could use Pythagoras' theorem. Now, this is going to be compounding your error because this is just an approximation. So that means that your adjacent side is going to be a further approximation. That's a good way to check your work. But a better way to do it is to apply your trigonometric ratios to try to find this side here, PS. So we're going to be using adjacent, and we're going to be using our original accurate measurement of 12.8. So in this case, hypotenuse and adjacent, well, this time we're going to be using cosine. So pause the video, and I want you to solve for side PS here. So what we're going to find is that the cos of 55 degrees is equal to PS over 12.8 meters. Using algebra, we find that PS is equal to 12.8 meters times the cos of 55 degrees, which is approximately 7.3 meters. So now that we know PS here, we also know PS here. The last step is to find the length SR. So pause the video and give that a try. So what we're interested in looking for here is SR. So we're looking for SR. We know our adjacent side, so that's the tan function. So we get a total of 4.2 meters. So the tan of 30 is SR over 7.3 meters. Using algebra, SR is equal to 7.3 meters times the tan of 30 degrees, which gives us an approximation to 1/10 of 4.2 meters. So Now let's take a look at all the information we've compiled. Well, we found out what SQ was. So SQ, this was 10.5. We found out that SR was 4.2, and now it's just a matter of subtracting these two to find out our final value, RQ. So 10.5 minus 4.2 gives us 6.3 meters, and this is accurate to 1 decimal place. So this is a multi-step problem. Notice that when you break it down, it becomes quite simple, but it takes training in order to figure out exactly how to approach it. So you'll be seeing homework questions that model the 4 examples that we took a look at today.